Okay, guys. So the next unit we're going to be working through is something called combinatorics. All right, so it's kind of a pretty interesting actual unit. Um, so the first lesson in it is on something called the fundamental counting principle. Okay, so I think this principle itself is easiest to explain through examples. All right, so I'm going to jump right into the first one here. Okay, so let's say we have a sandwich special, and it consists of choosing one item from each category in the following menu. Okay, so you can choose from the bread, the meat, the soup, and a beverage. Okay, so you're going to pick one of each, and we want to know how many different sandwich specials are there or are possible. Okay, so the way that you would get the total number of possible specials would be, and you may have already kind of intuitively figured that out, it would be that you multiply each number of options in each category. Okay, so, for example, for this example here, we have 4 categories. Okay. So the first category here, let me just scroll this out here. First category would be how many options for bread do you have? Next would be the meat, soup, and then the beverage. Okay. All right, so we have 2 options for the bread. We have 1, 2, 3, 4, 5 options for the meat. We have 3 different types of soup. We have 5 beverages to choose from. Okay. So to get the number of possibilities, we would actually just multiply these numbers together. Okay, so that's what's that? 10, 30, 150 possible specials. Okay, so that's basically it. What you would do, this is the fundamental counting principle, is that you would multiply the number of options for each category, and that should give you the total possible number of possibilities. Okay. All right. So let's just go on to the next one here. So how many ways can a family of 5 be arranged in a line if one parent must be at the front and the other parent is at the end? Okay, so we have 2 parents and 3 children. Okay, so they're in a line. So there's 5 of them. And what we want to do is figure out how many ways can we arrange this family. Right? Now the thing here is that one parent must be at the front and the other one must be at the end. So at the front here, we don't actually have 5 options. We only have 2 options. Okay, so it's going to be one of the 2 parents. And then at the end of the line, if one parent is at the front, the other parent, so we only have 1 option for the end there. Okay. Now this next slot here, the next, so the second person line is going to be a child, and there are 3 possible children that could go there. All right, and then the next would be you would only have 2 possibilities because one of the children is in the second slot here. Okay, so it reduces by 1, and then we only have 1 more option there. Okay, so we're going to multiply these together, and that's going to equal 12. Okay, so there are 12 possible ways of this family to be arranged. Right? If one parent is at the front and one parent is at the back. Cool. All right, so now the next couple, the last 2 examples here are a little bit more challenging. All right. Okay, so next up, we want to know how many non-zero sums of money are possible if you have 1 nickel, 1 dime, 2 quarters, 1 loonie, and 3 toonies. All right, so we got quite a few coins here to choose from, and basically what it's asking you is just from here, how many, like you can pick 1 coin, you can pick 2 coins, you can pick any number of coins, you can pick all of the coins, right? We just want to know how many different sums you get, so when you total up the value that you choose, right? So the way we're going to approach this is we're going to separate these into the different categories. So we have 1, 2, 3, 4, 5 different types of coins. All right. So the first one here would be nickels. This would be dimes, quarters, a loonie, and toonies. All right. So in the first position here for the nickels, we only have one nickel, right? However, there are two actual options, right? The reason there's two options is because you can choose one nickel or you can choose no nickels. Okay, so there's actually two options here. Okay, so either you do choose the nickel or you don't, right? Likewise for the dime, you're either going to choose the dime or you're not, so we have two options. Next up, since we have two quarters, there's going to be three options, okay? Because you can choose no quarters, you can choose one quarter, you can choose both quarters, right? The loonie, again, two options, and then three toonies, which means there are four options. Okay? So you can choose one toonie, two toonies, three toonies, or no toonies. Okay, so this would be the number of possibilities for each one of those coins. Now, when we multiply these together, we're going to get, what's that? 4 times 3 is 12. 12 times 2 is 24. 24 times 4 is 96. Okay, so there's 96 possible sums. However, this is not the right answer because this is kind of a key part here as well. We can't get 0, okay, which means the one combination where we have like no, 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 so we don't pick any coins, is not does not count. Right? So that means we have to subtract 1 from here. Okay, so again, this would be like when it does sum to 0. Okay, so if it does sum to 0, that would mean that you would have been choosing no coins at all. Okay, so we're going to subtract that one combination or that one possibility. So this would, the actual answer here would be 95. Okay, so there's 95 different sums. Cool. So that makes sense. All right. And now this last example, we have these digits here. So we're going to be using the digits 2, 3, 5, 6, 7, and 8. And we want to know how many 4-digit numbers larger than 3,700 can be formed if repetition is allowed and then not allowed. Okay, so we're going to actually split this. This is a kind of a two-part question, though it's written in one question. All right, so part A would be repetition allowed. Okay, so let's figure this out here. Now this one here actually is a bit tricky, okay, because we actually got to split this up into two separate cases. All right. So case 1 would be if the first digit is, let's see, 5, 6, 7, or 8. All right. The second case is if the first digit is 3. Okay. Now what you'll notice is the first digit can't be 2. Right. The reason it can't be 2, then obviously it's not going to be larger than 3,700. Now the reason why we had to split this up into the two cases is that for this first case, if the first digit is 5, 6, 7, or 8, then the second digit can be any one of these, right? Because automatically that number is going to be greater than 3,700. Right. Whereas in the second case, if the first digit is 3, then the second digit has to be a 7 or an 8. Right? It can't be like a 6 or a 5, or else it'll be less than. Right. So this is kind of a tricky question where we actually have to split this up into two cases. All right. So again, I'm just going to say that again. So I'm just going to repeat that. So in the first case, if the first digit is 5, 6, 7, or 8, then the second digit can be like any one of these numbers. Right? Whereas if it's the first digit is 3, then the second digit has to be a 7 or an 8. Right? It can't be a 6 or a 5 or any one of those because it would be less than 3,700. Okay, so this is why we need two separate cases. Okay, so in the first case here, again, it's a 4-digit number. We're just going to work out the number of possibilities for each one. Okay, so the first digit could be a 5, 6, 7, or 8. So that's 4 possibilities there. Now, in this case, the repetition allowed is allowed. So The second slot here can be any one of these 6 numbers here. So that would be 6, as with this one and this one here. Okay, so these would be multiplied together. So in the first case, this would be, I can't do that in my head. I'll just grab my calculator. Okay, so you're going to go 4 times 6 times 6 times 6. All right, so that's 864 possibilities. Okay, so another way to think about this is there's 864 possible numbers, 4-digit numbers, that are greater than 5,000. Now, for the second one here, the first digit is a 3. So there's only one possibility. You're locking in the 3 there. Okay. Now, if it's a 3 here, then to be larger than 3,700, we only have 2 possibilities for the second place. This can be a 7 or an 8. So you have 2 possibilities. Okay, so underneath here, I'll just write 7 or 8. Now this one is a 3. And the next digit, okay, it could be any one of these 6. And same with the last one. Okay. Now the reason why it's 6 and 6 is because repetition is allowed. You can use the same number twice. Right? You can use any one of those 6 digits here, any one of those 6 digits there. All right. So if you multiply these together, 2 times 6 times 6 is 72. All right. So to answer this first question, what we're going to do now is we're going to add these 2 possibilities together, or these 2 cases. All right, so when we add these together, let's just do that. 6, 3. In this, to answer the question there's 936 possible ways. All right. Okay, so for part B, where repetition is not allowed, okay, it's just going to change the question slightly. So repetition is not allowed. We are still going to need to split this up into the 2 cases. All right, so case 1. So the first digit is a, what's it, 5, 6, 7, or 8. All right, so in this first slot here, we have 4 possibilities. And in the second slot, there were a total of 6 digits, right? So actually, let's just, on the side here, I'm just going to list the digits. I think it was 2, 2, 3, 5, 6, 7, 8. Okay, so in this next spot here, we actually have 5 possibilities. Right? The reason it's 5 is because one of those digits was used, like a 5, 6, 7, or 8 was used in the first spot. So it takes away 1, right? Because you can't use the same one. Okay, so instead of 6, it's going to be 5. And likewise over here, it's going to be 4 and then 3. Okay, because there's, as we go down the line here, one slot, one of the digits has been used up in the previous slot. Okay. So when we multiply these together, 20 times, so that's 20 times 12, which is 240. All right, and then the second case is when the first digit is the 3. Then we'll have 1 possibility here. And then, so to be greater than 3,700, it's got to be a 7 or an 8. So we have 2 possibilities here. And then since repetition is not allowed, and we've used up 2 of the digits in the first 2 spots, there's, of the 6, there's only 4 left. Then there's 3 left here. Okay, so when we multiply those together, we get 24. And to answer this, we're going to add the 2 cases together. This will be 264. Okay, so 264 if repetition is not allowed. All right, guys, cool. So this is, yeah, the fundamental counting principle. All right, so um, that's kind of the basic idea. So the worksheet, where is it here? So the practice worksheet here um, is fairly short, actually. So there's only 6 questions here. Okay, so yeah, work your way through those, check your answers, all right, and hopefully this is making sense. All right, cool. All right, guys, have a good one. Bye.